All right, today we are peeling back the curtain on a really powerful real-world PHP architecture. We're going to break down exactly how you can build some incredible real-time interactive features using a stateful approach with something called server-sent events. You know, if you're a PHP developer, this question probably hits close to home. Things like live notifications, updating dashboards, or chat features, they can seem super complicated. It often feels like you have to reach for a totally different language or framework. But what if there was a native, scalable, and honestly, a surprisingly elegant way to do all of it right inside the PHP you already know and love? Well, there is. So to get our heads around this, let's start with a really simple but powerful analogy that's going to frame this whole discussion. I want you to think of server-sent events, or SSE, not as some complex tech, but just as a simple radio station for your data. This right here really gets to the heart of it. A lot of times we immediately think of WebSockets, and they're great, but they're like a phone call. It's a two-way, constant conversation, perfect for things like multiplayer games where data is flying back and forth. But SSE? That's our radio station. The server is the DJ broadcasting updates, and your browser just tunes in and listens. It's a one-way street. It uses standard HTTP, which means it plays nice with firewalls, and it is perfect for most of what we need. Notifications, live data feeds, you name it. Yeah, for so many use cases, SSE is that just right solution. Because it's just HTTP, it works everywhere, right out of the box. No special server setup. And get this, if the connection drops for a second, the browser automatically tries to reconnect. You don't have to write a single line of code for that. It's super lightweight on the client side, and because that connection just stays open, it is way, way better for battery life than constantly asking the server, anything new? Anything new?
Okay, so to really understand how this all clicks together, let's meet the cast. Think of it like a play. We've got 4 key players on our stage, all working together to create this real-time magic.
First up, we have the listener. This is just a little bit of JavaScript, our SSEManager.js, that's living inside the user's web browser. Its entire job is to tune the radio to the right station, our server's stream URL, and then just listen for whatever the DJ broadcasts. It's the radio itself. And look how simple it is on the client side. This one line of code is basically the entire engine for the client. That's it. It just tells the browser, hey, connect to this URL and listen. The browser then takes care of all the heavy lifting. It's beautiful. Next, let's meet the DJ, or you could call him the night watchman. This is our SseServer.php script. Now, this is not your typical PHP script that runs and then dies a few milliseconds later. No, this guy is a marathon runner. It's a long-running process that stays awake 24/7, holding open all those connections for every single listener and broadcasting the messages when they come in. So, a fair question. How does the DJ know what to play? Well, that's where the publisher comes in. This is just a standard, boring API endpoint, our SSEcontroller.php. When something interesting happens in your app, say a user sends a new chat message, it hits this controller. The controller's job is just to grab that new info and get it ready for broadcast.
And finally, we have the memory. This is our SseServer.php and the database behind it. You can think of this as the system's brain. It remembers every single message that needs to be sent out. And crucially, it keeps track of which listeners are tuned in to which specific channels or topics. This is what makes our whole radio station smart, or stateful.
Okay, so we've met our cast. Now for the fun part. Let's actually follow the journey of a single message as it zips through this entire system, all the way from the moment it's created to the instant it pops up on a user's screen.
And it happens in 5 ridiculously fast steps. First, your app publishes a new event to that API controller. The controller tells the service to store it in the database. Then, and this is clever, the service sends a tiny signal to wake up the DJ. The DJ wakes up, fetches all the new events it missed while it was napping, and finally broadcasts them to all the right listeners, all in milliseconds.
And this is probably the most clever part of the whole system. Instead of having our DJ constantly hitting the database asking, anything new yet? Which would be super inefficient, the SS service just sends this tiny little UDP packet. It's literally just a wake-up nudge. It's like a whisper that tells the sleeping DJ, hey, time to get to work. This makes the whole thing incredibly responsive without wasting any resources. Okay, so how on earth does one PHP script handle maybe thousands of listeners all at once? The secret sauce is this one powerful function, stream_select.
This is the beating heart of our server. It lets a single PHP process efficiently monitor thousands of network connections, plus that UDP wake-up signal, all at the same time. It basically just sits there, using almost no CPU until there's actual work to do. It's the key to the whole thing being so performant.
So look, an architecture isn't just about shuffling data around. It's got to be tough, it's got to be secure, it has to be ready for the real world. So let's look at how this setup bakes in some of those critical professional-grade features. Security is obviously non-negotiable. Our server has secrets, things like database passwords, that live in a .apn file. We can absolutely never let those leak to the browser. So we use what's called a security bridge. The browser asks a safe PHP script for the connection details. That script acts as a bridge, or go-between. It can see the secrets, but it only passes the safe public info, like the URL and port number, over to the browser. The secrets never, ever leave the server.
Okay, listen up, because this is a pro tip that will save you hours of pulling your hair out. In PHP, when a script opens a user session, it puts a lock on it. Now, since our SSE connection stays open for a long time, if we don't release that lock by calling session_write_close, other parts of your app for that same user will literally just freeze. They won't load. So every endpoint that deals with SSE has to do this immediately. Seriously, write it down, don't forget it.
So what happens if a user is on a shaky connection and their Wi-Fi drops for a few seconds? Well, SSE has this brilliant feature built right in, called the last event ID. When the browser reconnects, it automatically tells the server, hey, the last message I got from you was number 123. Our DJ sees this, checks the database for any messages after 123, and sends them all right away. It's basically a DVR for your data. Nothing ever gets lost. This whole setup works beautifully on one server, but the true test of any architecture is, can it scale? So let's talk about how we take this design from a single server to handling potentially millions of users.
The trick to scaling is pretty simple. We swap out that local UDP nudge for a distributed message bus, something like Redis pub sub. Now, when a new event happens, your app publishes it to a central Redis channel. Redis acts like a giant megaphone, instantly broadcasting that message to all of your SSE servers at once. Then, each of those servers just pushes the update to its own little group of connected clients. The load gets spread out, and you can scale this thing out as wide as you need to.
And really, this quote just sums it all up perfectly. For the developer working on the front end, it's just beautifully simple. Just listen to a URL. But on the inside, under the hood, it's a robust, stateful, and scalable system that's ready for some serious industrial strength work.
And that pretty much wraps up our deep dive. We've seen how this clever mix of native PHP, a smart database, and the simple SSE protocol can create some really powerful real-time experiences. So the last question I'll leave you with is this. When you think about your own projects, what real-time broadcast could your application be missing? Hope this got the wheels turning.